Alcohols, phenols, and ethers. After studying this unit, you will be able to name alcohols, phenols, and ethers according to the IPAC system of nomenclature. Discuss the reactions involved in the preparation of alcohols from alkenes, aldehydes, ketones, and carboxylic acids. Discuss the reaction involved in the preparation of phenols from haloarenes, benzene, sulfonic acids, diazonium salts, and cumin. Discuss the reactions for preparation of ethers from alcohols, alkyl halides, and sodium alkoxides, aryl oxides. Correlate physical properties of alcohols, phenols, and ethers with their structures. Discuss chemical properties of three classes of compounds on the basis of their functional groups. Alcohols, phenols, and ethers are the basic compounds for the formation of detergents, antiseptics, and fragrances, respectively. So, you have learned that substitution of one or more hydrogen from a hydrocarbon by another atom or a group of atoms resulting in the formation of an entirely new compound having altogether different properties and applications. Alcohols and phenols are formed when a hydrogen atom in a hydrocarbon aliphatic or and aromatically respectively is replaced by OH group. So these classes of compounds find wide application in industry as well as in day-to-day life. For instance, you have noticed that ordinary spirit used for polishing wooden furniture is chiefly the compound containing hydroxyl group ethanol. The sugar we eat, the cotton used for fabric, the paper we use for writing are all made up of compounds containing OH groups. Just think of life without paper, no notebooks, books, newspaper, currency notes, checks, certificates, etc. The magazines carrying a beautiful photographs and interesting stories would disappear from our life. It would have been really a different world. An alcohol contains one or more hydroxyl groups directly attached to carbon atom of an aliphatic system CH3OH, while a phenol contains OH groups directly attached to carbon atoms of an aromatic system C6H5OH. The substitution of a hydroxyl atom in a hydrocarbon by an alkoxy or a alkoxy group yields another class of compounds known as ethers. For example, CH3OH, CH3 dimethyl ether. You may also visualize ethers as compounds formed by substituting the hydroxyl atom of hydroxyl group of an alcohol or phenol by an alkyl or aryl group. So in this unit we shall discuss the chemistry of three classes of compounds, namely alcohols, phenols, and ethers. Classification. The classification of compounds makes this study systematic and simpler. Therefore, let us first learn how are alcohols, phenols, and ethers classified. Alcohols: mono, di, tri, or polyhydric alcohols. Alcohols and phenols may be classified as mono, di, tri, or polyhydric compounds depending on whether they contain 1, 2, 3 or many hydroxyl groups respectively in their structures as below. So this is monohydric, this is dihydric because of 2 OH groups, this is trihydric because of 3 OH groups. Monohydric alcohols may be further classified according to the hybridization of the carbon atom to which the hydroxyl group is attached. Compounds containing class C OH, that is sp3OH bond in this class of alcohols. The OH group is attached to an sp3 hybridized carbon atom of an alkyl group. They are further classified as follows: primary, secondary, and tertiary alcohols. So in these three types of alcohols, the OH group is attached to primary, secondary, and tertiary carbon atom respectively as depicted below. So this is primary alcohol, this is secondary alcohol because it is attached to secondary carbon, and this is tertiary alcohol. Allylic alcohols. In these alcohols, the OH group is attached to sp3 hybridized carbon adjacent to the carbon carbon double bond. So this is that is to an allylic carbon, for example. So this is carbon carbon double bonds and this is attached to that carbon, so having the carbon carbon double bond. So this is adjacent to the carbon carbon double bond. So this forms the allylic alcohols. Then this forms the alkylic alcohol but secondary. Then this forms the alkylic alcohol but tertiary, because here it's a allylic group and it's a the OH group is attached to that carbon having this 1, 2 and 3, but this is allylic also and this is tertiary also. Benzylic alcohols, in these alcohols OH group is attached to sp3 having as carbon atom next to an aromatic ring. So next to an aromatic ring, this is primary, this is secondary and this is tertiary. Benzylic alcohols. Allylic and benzylic alcohols may be primary, secondary or tertiary. Then compounds containing carbon having sp2 hybridization and OH bond. These alcohols contain OH group bonded to a carbon-carbon double bond, that is to a vinylic carbon or to an arylic carbon. These alcohols are also known as vinylic alcohols. So vinylic alcohol is having this structure. Then phenols, mono, di and trihydric phenol. This is monohydric phenol. This is dihydric because of 2H group. This is trihydric because of 3OH group. Next is ethers. Ethers are classified as simple or symmetrical. If the alkyl or aryl groups attached to the oxygen atom are the same and mixed, or unsymmetrical if the two groups are different. Diethyl ether CH2H5O C2H CH2H5O C2H5 is a symmetrical ether, whereas C2H5O CH3, this is methoxyethane, this is ethoxybenzene, are unsymmetrical ethers. Nomenclature. Alcohols. The common name of alcohol is derived from the common name of alkyl group and adding the word alcohol to it. For example, CH3, which is a methyl alcohol. According to IUPAC system, the name of an alcohol is derived from the name of the alkane from which the alcohol is derived by substituting E of alcohol with the suffix ol. The position of substituents are indicated by numerals. For this, the longest carbon chain, parent chain, is numbered starting at the end nearest to the hydroxyl group. The positions of OH group and other substituents are indicated by using the number of carbon atoms to which these are attached. For naming polyhydric alcohol, the E of the alkane is retained and ending OL is added. The number of OH groups indicated by adding the multiplicative prefix di, tri, etc. before ol. The positions of OH groups are indicated by appropriate locants like this, named as ethane 1,2-diol.